Maya Alochi, and in this video we will learn how to assign R and S configuration to chiral carbons. This configuration is assigned to specify the three-dimensional orientation of the four groups that are connected to the chiral carbons. So here we will go through my outline, and I will also teach you a trick of how to assign R and S configuration when the fourth group is not on a dash, and also we will go through a lot of examples to make sure that you learn the topic well. So let's get started. The first thing we need to do is we will have to find a chiral carbon. It's also called a stereocenter, sometimes it's called stereogenic center, chiral center, so it has a lot of different names, but basically it is a carbon that is connected to four different groups. And we will see how to identify these carbons, and you can also watch my other videos where I have showed how to identify the chiral carbons as well. Next, we will assign priorities 1 through 4 to atoms that are attached to the carbon, where 1 will be the biggest atomic number, and that's why I put the periodic table here, so we will look for the atomic numbers, and 4 will be the smallest atomic number. And then if we see that our carbon has 3 bonds only, we will draw in a hydrogen because that must be our fourth group. The third step is if the atoms are the same, we have to go atom by atom until the first difference in order to assign the priorities correctly, and I will definitely show you how to do that in the example. And then in the last step, what we will do is if our group 4 is dash, then we just connect 1 through 3 and determine the direction. If it's going clockwise, it will be R, and counterclockwise is S. So let's go ahead and look at how to do this. This is my example. First of all, I need to find a chiral carbon. So if I look at all the carbons here, I can check out this carbon and I can see what 4 groups does it have and are they different. So this carbon has a chlorine. It also has a methyl group here, 1 carbon here, and it has 2 carbons here. So far, all of these groups are different. Notice that this carbon has only 3 bonds. So where is its fourth group? Because every carbon wants to have 4 bonds. The fourth group must be hydrogen, and since chlorine here is on a wedge, my hydrogen must be on a dash. So I put a hydrogen in, so I can assign now my priorities correctly, and I have 4 groups to look at. This carbon is a chiral carbon because it has chlorine, hydrogen, 1 carbon on the left and 2 carbons on the right, making this carbon having 4 different groups and making it a chiral carbon. So I can put an asterisk here. If I look at any other carbons on the molecule, this carbon is connected to 3 hydrogens, so it cannot be chiral. This carbon is connected to 2 hydrogens. It cannot be chiral because they're the same. And this one again is connected to 3 hydrogens that are not shown, so this cannot be chiral either. So what do we do next? Let's just change the color. We're going to go atom by atom to assign priorities. So the first atoms that are coming off of our chiral carbon are chlorine, hydrogen, 1 carbon on the right and 1 carbon on the left. Notice I do not look at the whole molecule right away, at the whole group. I go atom by atom. So right now I have chlorine, hydrogen, carbon, carbon. Now, if we look at the periodic table, we will see that hydrogen has atomic number of 1. It is the smallest, so the smallest gets number 4. So my hydrogen is number 4. Now, if we go and we look at chlorine versus carbon, we will see that carbon has atomic number of 6 and chlorine 17. So chlorine wins. And as you do this more often, you will not have to look at the periodic table anymore. You will just remember who is bigger and who is smaller. But since chlorine is bigger than the carbon, I'm going to give it number 1. So again, we looked at the 4 atoms attached to the carbon here. And chlorine is the biggest, so it got number 1. Hydrogen is the smallest, and it got number 4. Now, the carbon on the left is attached to 3 hydrogens. The carbon on the right is attached to 2 hydrogens, And again, the hydrogens are not shown, but I know they're there because the carbon wants to have 4 bonds. So on the right, it is attached to 2 hydrogens and another carbon. So who wins? Who is bigger? I see a difference here because this carbon does not have any other groups other than hydrogens, but this carbon is attached to one more carbon. So this carbon must win, and therefore it will get number 2, and this group will get number 3. So I went ahead and I added the hydrogen because I saw that my carbon had only 3 groups on it. And then I assigned my priorities based on the atomic number. Chlorine has the biggest atomic number, so it got 1. Hydrogen has the smallest atomic number, so it got 4. And then between the 2 carbons, I saw that the carbon on the right is connected to one more carbon, while the carbon on the left is not. So carbon on the right won, and it got number 2, and carbon on the left got number 3. Now my group number 4 is dashed. This is very important because whenever we assign priorities, we always want the fourth group to be dashed. Since it's dashed, I don't have to do anything, and I just continue with my reasoning. I have to connect 1 through 3. So let me go ahead and connect 1 through 3. So 1, 2, and 3. It is going this way, and I have to determine the direction. Now, if when I connect the direction is counterclockwise, this is going to be S. If it clockwise, this is going to be R. And the way I remember R is I remember to the right. It kind of looks like it's going to the right. So for this one, when I connected my 1 to 3, I can see that the direction is going to the right, and therefore this will have R configuration. This chiral carbon has an R configuration. Let's go ahead and look at what happens if we have double or triple bonds and how to differentiate between them. So, the fifth point that I made is you should count a double bond as if the atom were connected to 2 other atoms, and we do the same thing for the triple bond, just with 3 other atoms. So if I have, for example, a C double bond C, it's the same as saying that that carbon is attached to 2 carbons. If I had, for example, a C double bond O, it would be the same as saying that carbon is attached to 2 oxygen atoms. So let's go ahead and look at this molecule. Again, we start by determining the chiral center. Now, a lot of times, once you see wedges on dashes, that's going to be your chiral center. Sometimes the professor might trick you and might give you wedges on dashes on a carbon that is not a chiral center if they decide to trick you. So you always have to check, do you have 4 different groups? And this carbon has OH, a hydrogen, and then on the left it has C double bond C, and on the right C single bond C. So the 4 different groups are there, so this carbon is chiral. Now let's go ahead and assign its stereochemistry. Again, we must go atom by atom. I see oxygen, hydrogen, carbon, and carbon. Oxygen, if you look at the periodic table, wins. It has the biggest atomic number, and therefore it will be number 1. Hydrogen will be number 4. Now I go to these 2 carbons. The carbon on the left is attached to the carbon on the right is attached to one more carbon. The carbon on the left, it has a double bond to another carbon, and we said that this double bond is the same as saying this carbon is connected to 2 other carbons. So we can think of this carbon as being connected to 2 other carbons, while the carbon on the right is only connected to 1 other carbon. And therefore, this side will win, so it will get a 2, and this side will get a 3. This group will get a 3. Now, let's proceed and let's connect 1 to 3. So 1, 2, 3 is going to go this way. And what is this? Which way are we going? This must be S. So far we have assigned our stereochemistry to 2 molecules, and the first one was R and the second one was S. But notice that in both of them, my lowest group, my group number 4, was dashed. Now, what do you do if the group number 4 is not dashed? Because in order to assign the stereochemistry correctly, it must be dashed. So in the textbook, they usually say that if the group is not dashed, you have to rotate the molecule three-dimensionally until that group is dashed, and then you have to figure out which way 1 through 3 will go. But this is really challenging for people who cannot see three-dimensional well, like myself. So there is a trick, and I took this trick actually from David Klein's book for organic chemistry, and he said that if your number 4 is not dashed, what you can do is you can switch number 4 with whatever group is on the dash. Then you have to determine the stereochemistry like we did before, and then we will say the opposite stereochemistry. Now, I have to tell you that some colleges just say if the group is not dashed, you just switch the stereochemistry and you're done. And most of the time that will work, and that's an even easier trick than this one. But this one will make sure, for sure, that you always get the correct stereochemistry. So let's go ahead and look at this molecule. I have a molecule here, and the first thing I do again is I have to find a chiral carbon, which is a carbon that is connected to 4 different groups, and I see a dash here, so that's a good start. So I see the carbon here has a dash OH. Now it doesn't show, it only has 3 bonds, it doesn't show the 4th bond, so I have to figure out myself that the 4th bond again must be hydrogen, because hydrogens a lot of times are not shown on the carbons, and because my OH was dashed, my hydrogen must be a wedge. Now let's look if it has 4 different groups. It has hydrogen, OH, benzene ring on this side, and chlorines on this. So definitely this carbon is a chiral carbon. And now we can assign our priority since it's the smallest. Now hydrogen is not always, it's not always going to be that your chiral carbon has to have any hydrogens. So then you're just looking at number 4, and we will see that actually going forward. We will do an example. But usually you do have a hydrogen and it gets number 4 because it's the smallest. Then we have oxygen, carbon, carbon. Again, I must go atom by atom. So the 3 atoms attached to my chiral carbon are oxygen, carbon, carbon, oxygen wins number 1. Now, carbon, carbon, no difference. This carbon on the right is attached to 2 chlorines and another carbon. On the left, my carbon is attached to 2 carbons, but it has a double bond, so it's like saying it's attached to 3 carbons. Who wins? Carbon that is attached to 3 carbons, or carbon that is attached to 2 chlorines and 1 carbon? If you look at the periodic table, you will see that chlorines have a higher atomic number than carbons. Therefore, the right side will win, and this is going to be 2, and this is going to be 3. Now I notice that my hydrogen is not, my lowest group, which is the hydrogen, my group number 4, is not on a dash. So what I will do according to the trick is I will secretly switch 4 and 1. Now this is just for you because the correct priorities are the ones that I have shown here. So this is just for you to figure it out, and you can erase it after. And then once I switch 4 and 1, so I switched my group number 4 with whatever group what is on a dash, because my group number 4 wants to be on a dash. So I switched with OH. So this was 4 and 1, and I gave the OH 4, and this is 1. And now I go ahead and I do my 1, 2, 3 squiggle. So we go 1, 2, 3, and it looks like it's going to go to the right in a clockwise direction. So it looks like it would be R, but I have to say the opposite stereochemistry. So I am going to say that this is S. So let's just go over this problem again. If your lowest group, if your group number 4 is not on a dash, what you do is you switch it with the group that is on a dash. Then you connect 1 through 4. So I connected 1, 2, 3. I'm sorry, I meant to say you connect 1 through 3. So I connected 1, 2, 3, and it's going in a clockwise direction. But then what you're supposed to do is you're supposed to say the opposite of the stereochemistry. So if it would be going this way, that would be R, but I'm saying the opposite stereochemistry. So I assigned it the configuration of S. Now let's go ahead and have more practice so we'll really solidify our RS configuration knowledge. And if you want, you can take a little bit of time to do it yourself to figure out R and S. So you can pause the video and you can come back once you have figured out and do it with me. Okay, now let's get started. So let's start with A. For A, we have to again find the chiral center, and I bet it's going to be this carbon. This carbon has a chlorine. It's connected to carbon on this side, but on this side it has a double bond, so that is different. And it has only 3 bonds, which means it's missing the fourth bond, which must be a hydrogen, so I show hydrogen. And because the chlorine was a wedge, my hydrogen will be a dash, which will make my life a lot easier because again, if the fourth group is on a dash, you don't really have to do any switcheroos. So let's go ahead and look at this chiral carbon and assign the priorities now. I have chlorine, hydrogen, carbon, and carbon directly attached to my chiral carbon. Hydrogen gets number 4. Chlorine, if you look at the periodic table again, gets number 1. Then I have 2 carbons. There's no difference between them. But the carbon here is attached to one more carbon. But the carbon here has a double bond, which counts as 2 carbons. So we can say the carbon here is attached to 1 carbon, but the carbon here is attached to 2 carbons. So this wins. So this will get 2, and this will get 3. 1, 2, 3. I'm going to the right. So this must be R. Okay, let's move on to part B. In part B again, probably this is the chiral carbon since it has our wedge. So let's look if it is. It has a methyl group here, just one carbon here, C double bond O here, and here it has a carbon that's connected to another carbon. So far all of the groups are different. And then it also has only 3 bonds, which means we're missing the fourth bond, and that must be hydrogen. And since this was a wedge, my hydrogen must be a dash. Next, we can assign our priorities. Hydrogen gets number 4 since it is the smallest. Now, let's look at these ones. Connected to my chiral carbon, I have carbon here, carbon here, carbon here. Right now, there's no difference. However, notice that carbon here is connected to an oxygen, carbon here is connected to a carbon, and carbon here is connected to hydrogens only. So the carbon that is connected to the oxygen wins. I'm going to give it a 1. And then between these 2 carbons, this carbon is connected to another carbon, but this carbon is only connected to hydrogens. So the carbon on the bottom must win. It's going to get a 2. And this carbon will get a 3. Now, if I notice that my hydrogen, my lowest group, is going in. It's a dash. So that means my life is much easier. I don't have to do much. I just have to connect my groups. 1, 2, 3, 1, 2, 3. And it looks like it's going in the S direction. This is S because it's going counterclockwise. And let's go ahead and look at part C. So this is the hardest out of all the ones I have given you so far, and we will look at it very carefully and assign our priorities very carefully. Let's first start with, I guess, this one. It has chlorine, an ethyl group, and then if we go to the top, it's connected to the OH eventually, and this one is not. So we can see that it is connected to 4 different groups, and we're going to go ahead and assign their priorities. I have to this carbon, I have chlorine. Now EC stands for ethyl. If it's easier to write instead of ET, I can just write 2 carbons. So 1 carbon, 2 carbons. Maybe I should use black so at least it's the same color. Now let me change my color again. So let's go ahead and look at it. So I have chlorine, I have carbon here, and carbon here. So the 4 atoms directly attached to my chiral carbons are chlorine, carbon, carbon, carbon. Out of all the carbons and chlorine wins and it gets number 1. Now, carbon here is attached to another carbon here is attached to another carbon, and carbon here is attached to another carbon. So far we see no difference. So we have to keep on going until we find a difference. Carbon here is attached to hydrogens only. Carbon here is attached to an oxygen and a carbon and another carbon. Carbon here is attached to 1 carbon, 2 carbons, 3 carbons. So out of the 3 groups, this one must be the smallest because this carbon is not attached to any more carbons, and I will give it number 4. This carbon is attached to an oxygen. This carbon is attached to other carbons. Oxygen has a bigger atomic number than the carbon, so therefore going this way will win over going this way. The top will win. So this will be 2 and this will be 3. Now I have to see if my lowest group is on a dash. And notice that here the lowest group actually was not a hydrogen, it was another group, but that does not matter. Usually the lowest group is a hydrogen, but not always, as you can see in this example. So my lowest group is on a dash, which makes my life easier. So I just connect 1, 2, and 3, 1, 2, and 3, and it's going in the clockwise direction. Actually, no, it's going in the counterclockwise direction. Sorry, it's not going to the right. And this is going to be S. And again, let me just repeat what we just did. So I had chlorine, carbon, 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 chlorine, what? We got a 1. Then each carbon was connected to 1 more carbon, 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 carbon. This carbon was connected to another carbon, and this carbon was connected to another carbon. The carbon here was only connected to hydrogens, whereas these 2 were connected to other things. So this one got a 4. And between these 2 carbons, the top one was connected to an oxygen, and this one was connected to carbons only. So this one had a higher priority and got number 2 and 3. Because my lowest group was on a dash, I just could connect my numbers, and I went 1 through 3, 1, 2, 3. So we went counterclockwise and we got an S configuration. Now let me erase it because it will get too confused. It will get too confusing. And we will do the other. Let's try to erase it to the best of my ability. Okay, almost there. Okay, perfect. Actually, what I'm going to do is I'm just going to copy this molecule over so I can also do another stereogenic center later on, because there are 3 of them here actually. This one is extra complicated. So now let's look at this carbon. This carbon is connected to an OH group, it's connected to a methyl group, and if you go to the left, it has these 2 groups, and if you go to the right, it has these 2 groups which are different. So this carbon is a stereogenic carbon, and we're going to go ahead and we're going to assign priorities to all the groups that it is connected to. So here we have oxygen, carbon, directly attached to my stereogenic carbon, carbon, and a carbon. So far we see a difference. The first difference is the oxygen. Oxygen has a bigger atomic number than a carbon, so it gets 1. My carbon my carbon here is not attached to any other carbons. It only has 3 hydrogens. My carbon on the right is attached to another carbon, and my carbon on the left is attached to another carbon as well. So this carbon loses and it will get a 4. because it does not have any other attachments other than hydrogens. And now we will check between these two ways, to the right and to the left, carbon carbon, no difference. And again, we cannot look at the whole big molecule. We have to go atom by atom until we find the first difference. I cannot emphasize it greatly enough because a lot of students make a mistake of just looking at the whole group and saying that group is bigger. But no, you have to go atom by atom until you find the first difference. So we go carbon, carbon, no difference. Then carbon, carbon, no difference. Now this carbon on the left is attached to one carbon, another carbon, and another carbon. So it's attached to three carbons. The carbon on the right is attached to a carbon here, a chlorine, and another carbon. So on the right, it has two carbons and a chlorine. So who wins? The right side, because this carbon is attached to chlorine, and chlorine has a higher atomic number. So the right side gets a 2, and this must be a 3. Now we ask ourselves, is our lowest group on a dash? And we see that it is not. So what we're going to do according to the David Klein trick is we're going to just replace 1 with 4. We will replace the group that is on a dash. We will give it 4. So we will exchange the group that's at that lowest group with the group that is on a dash. So I'm going to give this a 4 and this is a 1. And so now I assign my configuration. I connect my 1 through 3 after I have assigned my priority. So I have 1, 2, 3, and it looks like it's going to the right. But because I did not have my group, my fourth group on a dash, I have to switch my stereochemistry. So I go 1, 2, 3. It's going to the right, which means R. But I have to switch my stereochemistry, and therefore this carbon will be S. So far this carbon is S, and this carbon has an S configuration also. And let's go ahead, and you can see that this molecule is a little bit of a more complicated case. So take your time going thoroughly through it. And let's go ahead and do the last chiral center here. This carbon is connected to a methyl group. This group, it also is different as we go to the top and to the bottom. So I can see that this carbon is a chiral carbon. And let me just go ahead and erase this so we're not as confused. Now let's go ahead and assign priorities, and again we must go atom by atom from the chiral carbon. So what atoms is this chiral carbon attached to? We have carbon, 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 carbon. Right now, no difference. We cannot assign anything yet. Now notice that this carbon is only connected to 3 hydrogens. This carbon is connected to another carbon. This carbon is connected to another carbon, and this carbon is connected to another carbon. So this carbon loses. It's only connected to hydrogens, while the rest have more carbons that they're connected to. So this gets a number 4. Now let's look at each carbon separately. So we had these 3 carbons, and which one of them was connected to another carbon? So carbon here, and carbon here. No difference. Now carbon on top is connected to oxygen, carbon, and carbon. Carbon here is connected to 2 carbons. And carbon here is connected to chlorine, carbon, and carbon. Now, out of all the atomic numbers presented here, chlorine has the biggest atomic number. So this group will win. This would be 1 because this carbon is connected to chlorine and 2 carbons. Now the next group should be this group, because let's go ahead and differentiate between these two. This carbon is connected to 1 oxygen and 2 carbons, and this carbon is connected to 2 carbons only. So the oxygen has a bigger atomic number and it wins. So this would be number 2 and this would be number 3. So we have assigned our priorities 1 through 4. And now we're going to see, is my group number 4, is it on a dash? And it is not. So what I'm going to do is, in my mind, I'm just going to switch it. Now, these are the right priorities. If you present it to your teacher, these are the correct priorities. So what you're doing now is a trick that you should erase after probably. So I switch my group number 4, but whatever group is on a dash. So in this case, it's this group. So I'm going to switch, and in small letters, I will write 4 here and 3 here. And honestly, usually you can just say the opposite stereochemistry and you will be correct 90% of time without switching these groups. But I think his trick is more thorough and it always should work. So a little bit of work just to be always correct. So next, what are you going to do? Are you going to connect 1 through 3? 1, 2, 3. And it looks like it's going in the S direction. It's going counterclockwise. But because my fourth group was not on a dash, I have to say the opposite stereochemistry. And the opposite stereochemistry of S is R. So I go ahead and I saw R. I assigned R to this carbon. Once again, this is Maya from Transformation Tutoring, and I really hope that you found this video helpful. Let me know how your R and S configuration assignment is going and what you're struggling with or what you're finding helpful. And I really look forward to seeing you in more of my organic chemistry as well as general chemistry videos.